हेलो एवरीवन, फिर से स्वागत है केमिस्ट्री क्लास में। आज हमें इस क्लास में या इस वीडियो लेक्चर में डिस्कस करेंगे 18th ग्रुप एलिमेंट्स, जिसको हम लोग कहते हैं इनर्ट गैसेस और नोबल गैसेस और रियर एलिमेंट्स। तो अब चलते हैं, शुरू करते हैं ग्रुप 18 एलिमेंट्स। सो हेडिंग इज ग्रुप 18 एलिमेंट्स। इस एलिमेंट्स को हम लोग कहते हैं नोबल गैस और इनर्ट गैस। फर्स्ट ऑफ ऑल इसको हम लोग डिफाइन करते हैं कि जिसमें जितने भी एलिमेंट्स है इसको हमने क्यों नाम रखा गया नोबल गैस और इनर्ट गैस। इस पर्टिकुलर ग्रुप में जितने भी एलिमेंट्स है सभी गैसेस है, इसलिए इसका नाम रखा गया गैस। नोबल गैस और इनर्ट गैस, इसका मतलब they are very unreactive, और their reactivity is very poor। इसके वजह से ये नोबल गैस और इनर्ट गैस है। अब सवाल ये कि why they are very unreactive? The reason being they have octet configuration। तो ग्रुप 18 में जो एलिमेंट्स है इसका वैलेंसी सेल इज कंप्लीटली ऑक्युपाइड। ऑक्टेट मतलब हैविंग 8 इलेक्ट्रॉन्स इन द वैलेंसी सेल। तो जब इलेक्ट्रॉन्स जितना इसके पास होना चाहिए वैलेंसी सेल उतना अगर है तो ना देने की जरूरत है ना लेने की जरूरत है। तो इसकी वजह से these elements are very unreactive। because of this poor reactivity these elements are known as noble gas or inert gas। group 18 elements, these elements general electronic configuration of these elements means we are just discussing the valency cell electronic configuration। They have this configuration NH2 NP6। so look at this, S orbital is completely occupied, P orbital is also completely occupied। so total number of electrons here is 6 plus 2 8, so this is octet। this N is valency cell or the outermost shell in which electron is occupied। now in this there is no unpaired electron, so all these noble gas or inert gas does not have any unpaired electron। तो अब ये इसमें देखिए this is NH2, so we have 2 electron here, then NP6, so all electrons are completely paired होते हैं, तो कोई भी unpaired electron है नहीं, इसलिए ये octet कंप्लीट है। तो 6 plus 2 टोटल 8 इलेक्ट्रॉन्स, तो इसका नाम रखा है ऑक्टेट कॉन्फ़िगरेशन। तो ये है जनरल इलेक्ट्रॉनिक कॉन्फ़िगरेशन जिसमें कोई अनपेयर इलेक्ट्रॉन्स है नहीं। एंड ग्रुप नंबर इज 18, नंबर ऑफ इलेक्ट्रॉन्स इन द वैलेंसी सेल इज 8। तो वैलेंसी सेल में 8 इलेक्ट्रॉन्स है, इसका नाम रखा गया ऑक्टेट कॉन्फ़िगरेशन। नाउ कमिंग टू जनरल एलिमेंट्स ऑफ दिस ग्रुप 18। Now normally this, look at this group 18, ये हम लोग कहते हैं p block elements. And this p block elements, look at this, last electron is entering in p orbital, but इसमें हम लोग हीलियम भी इंक्लूड करते हैं जिसका इलेक्ट्रॉनिक कॉन्फ़िगरेशन इज 1s2. सो हीलियम इज नॉट ए p block element, but the property of this helium element is found to be similar to the elements of group 18, that is p block. So this helium is grouped along with these elements. So we have these elements: helium, neon, argon, krypton, xenon, and the last one. So the last random, the last one is radioactive. So since the last element, radon, being radioactive, its chemistry is less known. So we are going to focus on the chemistry of this helium, neon, argon, krypton, xenon. So if you look at this is p block element. Where is this helium? This must be s block element because the last electron is entering in s orbital. So this has got octet, but this has got duplet configuration, and this has got octet configuration. So valency cell is completely occupied, so its reactivity is very poor. So this is a noble case. Now reactivity very poor का मतलब ये नहीं है कि वे react ही नहीं करेंगे, react करते हैं, but the number of compounds formed by these noble gases is very less. So these are known as less reactive or poor reactivity. Now coming to general features of these elements. General features, so we have these elements: helium, neon, argon, krypton, xenon, and the last one is radioactive. So we are just not focusing on this, the last element. Now first of all, look at this. Let's discuss the size of these elements. Now moving from top to bottom, the size of these elements increases from top to bottom. That is normal, expected. So why size increases? Because of addition of extra cells, size increases. Now if you look at this, in a period, moving from left to right in a period, size decreases due to increase in effective nuclear cells. But when we compare the size of this group 18 and those of elements on the left side of this group 18, this in a particular period the size of noble gas is the largest. अब होना क्या चाहिए था? Smallest size in a period किसका होना चाहिए था? Noble gas का. But in reality, the size of noble gas is the largest in a period. So the reason being, in this noble gas, the radius is measured in terms of non-bonded interaction, that is van der Waals radii. Due to the presence of 8 electrons in the valence cell, there is a repulsive force, and this repulsive force and measurement in terms of non-bonded interaction van der Waals radii makes the radius of these elements to be the largest in a given period. So don't be under this confusion because this is on the extreme right hand side, so इसका size सबसे कम होना चाहिए, but in reality the size of noble gas सबसे ज़्यादा है. Reason कि ये octet configuration है, तो number of repulsion is more. Second, इन सभी का रेडियस van der Waals रेडियस जो कि नॉन बॉन्डेड इंटरेक्शन से मेजर किया गया है, इसलिए इनका साइज सबसे लार्जेस्ट है इन ए पीरियड. Down the groove, size normally increases because of addition of extra shell. atomicity. Now all these elements, मैंने आप अभी just heading दिया था noble gases या inert gases, the reactivity कम है, the reason being either duplet configuration है और octet configuration in the valency cell है. तो इन सभी elements in elemental state atomicity is 1. Monoatomic gases, all these are monoatomic gas. तो अगर ये गैस है तो ऑब्वियसली मेल्टिंग पॉइंट बॉइलिंग पॉइंट तो कम ही होगा. नाउ कमिंग टू मेल्टिंग पॉइंट एंड बॉइलिंग पॉइंट. द मेल्ट फर्स्ट थिंग कि फिजिकल स्टेट सभी गैसेस एट रूम टेम्परेचर सभी एग्जिस्ट करते हैं गैस स्टेट. So now look at this, the melting point and the boiling point of all these noble gases are very low. Melting point, boiling point is low. So why low melting point and boiling point? Because the intermolecular attractive force, that is weak van der Waals force. So low due to weak van der Waals force of attraction. तो सभी एलिमेंट्स ऑफ ग्रुप 18 melting point boiling point low है. Reason is due to weak van der Waals force of attraction between the molecules. Now moving down the group, हम लोग डाउन द ग्रुप चलते हैं. डाउन द ग्रुप साइज इंक्रीजेस. अगर साइज इंक्रीज करते हैं तो ऑब्वियसली सरफेस एरिया भी इंक्रीज क्या होगा. सो ड्यू टू इंक्रीज इन साइज फ्रॉम टॉप टू बॉटम और हीलियम टू जेनन, द strength of van der Waals force increases. As the strength of van der Waals force increases, the melting point as well as the boiling point of these elements increases down the group. So melting point, boiling point increases down the group due to increase in strength of van der Waals force. So why strength of van der Waals force increases? Because of increase in size. Because of increase in size, intermolecular attractive force increases down the group. As a result, melting point and boiling point increases down the group. Density of the elements again increases down the group. Down the group, volume also increases, mass also increases. So density is defined as the ratio of mass per unit volume. So down the group, increase in mass is greater than increase in volume. So moving down the group, density of these elements also increases. Ionization potential or ionization energy. The ionization energy of group 18 element is very high, and when we compare ionization energies of all elements, the ionization energy of elements are much greater than that of the remaining elements. So in a particular period, the ionization energy of noble gas is the largest. Now why ionization energy is largest? Again, because all these elements have octet configuration. So already octet configuration है, so that is a very stable configuration. So to remove this electron means you have to break this stability. So to destabilize, you have to supply a large amount of energy. As a result, the ionization energy is very high. So ionization energy of noble gas is very high, in fact the largest in a particular period. So The reason is due to octet configuration. So highly stable octet configuration, and to break this stability you have to supply large amount of energy. However, moving down the groove, as the size increases, the distance between the valence electron and the nucleus increases. As the distance increases, the electrostatic force of attraction between electron and the nucleus decreases. As the attractive force decreases, the tendency for removal of electron increases, means the ionization energy decreases down the groove. So what I am saying is, their ionization energies are very high because they have octet configuration. But down the groove, size increases. Because of increase in size, distance between the valence electron nucleus increase करेंगे. जैसे जैसे डिस्टेंस इंक्रीज करेंगे, एट्रैक्टिव फोर्स कम होते जाएंगे, तो इलेक्ट्रॉन्स को निकालना और आसान हो जाता है. सो नॉर्मल जो ट्रेंड है, down the groove ionization energy decreases because of increase in size. Electron gain enthalpy. Electron gain enthalpy values. Now look at this. Moving from left to right, electron gain enthalpy values generally increases, because moving from left to right, size decreases. As the size decreases due to increase in effective nuclear charge, attractive force between the added electron and the nucleus increase करेंगे. जैसे जैसे attractive force बढ़ते जाएंगे, energy released during addition of electron भी increase करते जाएंगे, becomes more and more negative. But if you look at this electronic configuration of this noble case, इनके पास octet complete है except for this helium. तो अगर octet या duplet complex complete है, तो इलेक्ट्रॉन किसको ऐड करेंगे? जब इलेक्ट्रॉन ही ऐड करना है, तो आपके पास स्टेबिलिटी जो था ऑक्टेट और डुप्लेट का, वो आपको डिस्ट्रॉय करना पड़ेगा. दैट मीन्स टू डिस्ट्रॉय द स्टेबिलिटी ऑफ ऑक्टेट और डुप्लेट, you have to supply enormous amount of energy from external source. That means the electron gain enthalpy values of these elements are positive, large, positive. So again reason is due to octet configuration or duplet configuration in the valency cell. तो ये इलेक्ट्रॉन गेन एंथैल्पी वैल्यूज है. So we have this ionization enthalpy, electron gain enthalpy, density, etc. तो now ionization enthalpy down the groove decrease कर रहे हैं. तो अगर डाउन द ग्रुप डिक्रीज करेंगे, तो रिएक्टिविटी क्या होना चाहिए? डाउन द ग्रुप इंक्रीज करना चाहिए. एंड नॉर्मल इफ यू लुक एट दिस, हीलियम, नियन, आर्गन के कंपाउंड्स अभी तक डिस्कवर नहीं हुआ. व्हाइल्स वी हैव अ नंबर ऑफ कंपाउंड्स ऑफ जेनन, वेरी फ्यू कंपाउंड्स ऑफ क्रिप्टन भी डिस्कवर हुआ. तो ये इससे पता चल जाता है कि डाउन द ग्रुप आयनाइजेशन एनर्जी डिक्रीज करने से रिएक्टिविटी स्लाइडली इंक्रीज करेंगे, एंड मैक्सिमम कंपाउंड्स किसका मिलेंगे? जेनिन्स का मिलेंगे. नाउ कमिंग टू solubility in water, ये आपके पास लोग these elements are very having very poor solubility in water. solubility बहुत कम है, but however ऊपर से जब नीचे चलते हैं तो solubility slightly increases. Poorly soluble in water, तो solubility बहुत कम है, लेकिन अगर डाउन द ग्रुप चलती है solubility slightly increase करते हैं. तो ये सब some physical properties है. Now coming to chemical properties, because number of chemical compounds or chemical reactivity of this compound is very matlab few, so we have to define the chemical properties here. अच्छा, फर्स्ट ऑफ ऑल हमें थोड़ा सा हिस्टोरिकल बैकग्राउंड में चलेंगे। फर्स्ट नोबल गैस का कंपाउंड्स कैसे डेवलप हुआ। फर्स्ट जो नोबल गैस का जो कंपाउंड डिस्कवर हुआ उस साइंटिस्ट का नाम है बर्टलेट एंड लोहमान। ये जो साइंटिस्ट है इसने फॉर द फर्स्ट टाइम नोबल गैस का कंपाउंड बनाया। अच्छा, नाउ दीज साइंटिस्ट first oxidize molecular oxygen by use of a very powerful oxidizing agent, that is platinum hexafluoride, which is one of the strongest oxidizing agent। अब ये dense fume से, reddish brown dense fume से, now this is very powerful oxidizing agent। So when oxygen gas is made to react with this platinum hexafluoride, now oxygen gas is oxidized। तो ऑक्सीजन गैस इज ऑक्सीडाइज किया। तो ये जब ऑक्सीडाइज किया तो इन्होंने ये दिमाग लगाया कि जेनन, the element xenon, the ionization energy or the first ionization energy of xenon is almost same as that of oxygen। If oxygen can be oxidized by this strong or powerful oxidizing agent, then why cannot xenon be oxidized by platinum hexafluoride? Because both oxygen and xenon is having almost similar ionization energy, so they carried out this reaction xenon plus PTF6 when they were able to oxidize xenon again। The ionization energy of almost similar ionization energy। So if oxygen can be oxidized, then why cannot xenon be oxidized? So based on this analogy, they reacted this xenon noble gas with this platinum hexafluoride and they were able to isolate a yellow color substance। Reddish fumes in। So when these reddish fumes is meant to react with this noble gas, they were able to isolate a yellow color substance। And now since the color has been changed, that means some chemical reaction has takes place। So the only possibility is, since this being a very powerful oxidizing agent, this must oxidize xenon, and the compound was found to be this। So this was the first compound that was discovered from this noble gas। So we have a limited compound, so we are focusing on this element xenon। So xenon reacts with fluorine। If suppose this is taken is 2:1 ratio, this gives you XeF2 xenon difluoride। If this mixture is taken in 1:5 ratio, then this gives you XeF4। But if this is taken in 1:20 ratio, then this gives you XeF6 difluoride, tetrafluoride, hexafluoride। And coming to the structure of this, with this XeF2, this is the central atom, so electron pairs is number of electrons in the valence shell of noble gas 8, number of other atom is 2 divided by 2, so we have 5 electron pairs, Number of other atom is 2, so we have 2 bonded pair and remaining 3 is lone pair. Now since there are a total of 5 electron pairs, so to place these 5 electron pairs we require 5 hybrid orbitals, and the hybridization is sp3d2, sorry, sp3d. So since this being sp3d, the geometry of the compound should be trigonal bipyramidal. So we have this xe. So in trigonal bipyramidal geometry, lone pair occupies the equatorial position. So if you look at this is having 3 lone pairs and the shape of molecule is linear shape. So geometry is trigonal bipyramidal, but the shape is linear. Coming to XCF4, xenon tetrafluoride. Again, this xenon is central atom, so we'll find out electron pairs here. So 8 plus 4 by 2, so we have 6 electron pairs. Now number of other atom is 4, so there must be 4 bonded pair and the remaining 2 is on lone pair. Since total 6 electron pair is present in the valency shell, so how many hybrid orbitals is required? 6. So the hybridization has to be sp3d2. So this must be octahedral. So look at this shape. So we have xe. Now we have 2 lone pairs and 4 bonded pairs. So fluorine occupies here, and we have this lone pair. So number of lone pair is 2 here. So geometry is octahedral, but the shape of the molecule is square planar. This is the square planar. So shape includes only the bonded pairs of electrons. Then we have XeH6 and xenon hexafluoride. We have this electron pair, that is 8 plus 6 by 2, so we have 7 electron pairs. Now number of other atom is 6, so we have 6 bond pair and 1 lone pair. Now since total number of electron pairs present is 7, so at least we require 7 hybrid orbitals. So the hybridization is sp3d3 type. So sp3d3 type should have been pentagonal bipyramidal, but experimentally it is found to be distorted octahedral. Xe. So we have fluorine, fluorine, fluorine. So we have 6 bonded pair and 1 lone pair. Now when we join all this, then this gives you octahedral. Now we require this lone pair. Now this lone pair is oriented along the centers of any edge. So because of this, lone pair, there is slight distortion in the octahedral geometry. So this is known as distorted octahedral. Why there is a distortion? Because of this lone pair. So this is pointed along the centers of any particular edge. Because of this, there is a distortion in octahedral. So these are the shape, geometry, hybridization, number of bond pairs and number of lone pairs. These general fluorides reacts quantitatively with hydrogen. So let's take up this reaction. Should I rub this? Yes. Now let's proceed further. HCF2 reacts with hydrogen gas and this gives you Xe plus 2HF. So look at this. This HCF2 is acting as an oxidizing agent. This hydrogen is acting as a reducing agent. So HCF2 reacts with 1 mole of hydrogen gas to give you 1 mole of Xe and 2 moles of HF. XeF4 reacts with 2 moles of hydrogen to give you Xe plus 4HF. XeF6 reacts with 3 moles of hydrogen gas to give you Xe and 6 moles of HF. So this is the reaction with hydrogen. Now these general fluorides also reacts with water. Then a reaction of this general fluoride with water is highly explosive or violent. So we have look at this. XeF2 reacts with water. This gives you Xe, HF and oxygen. XeF4 reacts with water when this gives you Xe, XeO3, HF and oxygen. Now this XeF6 reacts with water in different way. XeF6 reacts with H2O when this gives you XeOF4 plus 2HF. This is partial hydrolysis. Similarly, look at this. XeF6 reacts with H2O. This gives you XeO2F2 plus 4HF. So these two reactions of XeF with water, this is known as partial hydrolysis. This XeF6 reacts with water, that is complete hydrolysis, when this gives you XeO3 plus HF. So we have this XeO3, XeO2F2, XeOF4. That is, this is complete hydrolysis. So that means these general fluorides on hydrolysis gives you different products. Now coming to this XeO3, XeO2F2 and XeOF4. Look at this XeO3. Xenon is your central atom, so the electron pair is 8 plus 0 by 2, so we have 4 electron pairs in the valency cell of this xenon in this compound. Number of other atoms is 3 oxygen, so we should have 3 bonded pairs and 1 lone pair. Now total of 4 electron pair is present, so the hybridization should be sp3, so the molecule should be tetrahedral, but the shape should be different from tetrahedral. So we have, look at this, O, 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 and this position is occupied by lone pair. So look at this, geometry is tetrahedral, but the shape is pyramidal, that is of ammonia type. Whereas this XeO bond, this bond is found to be having triple bond, so this bond is p pi d pi, because this xenon has got vacant d orbital and this oxygen has got electrons in p orbital, so there is a transfer of electron density from filled p orbital of oxygen to vacant d orbital of xenon. Now XeO F4, so this is again central atom, so we have electron pairs 8 plus 0 plus 4 by 2, so we have 6. Number of other atom is 4 plus 1 5, so we have 5 bonded pair and 1 lone pair. So hybridization has to be sp3 d2, so octahedral, so we have this Xe, so we have fluorine, 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 so we have oxygen, we have 1 lone pair. So shape, here shape is pyramidal, here shape is square pyramidal, XeO2F2, again X is central atom, so we have electron pairs 8 plus 0 plus 2, 2 fluorine divided by 2, so we have 5 electron pairs. Now number of other atoms is 4, 2 plus 2 4, so we have 4 bond pairs and 1 lone pair. So if you look at this, these three contains 1 lone pair each. So number of electron pair is 5, so we require 5 hybrid orbitals, so hybridization is sp3d. So we have Xe, so in trigonal bipyramidal geometry, lone pair always occupies equatorial position and the most electronegative atom always occupies axial position, so these two axial position is occupied by fluorine and equatorial position is occupied by oxygen. So we say this is seesaw shape. So this is some of the important compounds and their reactions. So halogens is noble gas is mainly focused on these general fluorides, and there are some reaction with hydrogen and reaction with water, their shape, hybridization geometry, and number of electron pairs present in the valency cell, lone pair, bond pair, etc. So this is all about noble gas. So with this we'll conclude the noble gas and some other properties of noble gas, like helium is the element with the lowest boiling point of all the elements present in the periodic table. Helium has got the lowest value of boiling point. Second, this helium is used in the by scuba divers, those swimmers which go inside the deep of the ocean, has got some tank. Inside this tank they use helium gas with other gases like nitrogen and oxygen. So why helium gas is used by scuba divers in oxygen container tanks? The reason is helium gas is very less soluble or very poor soluble in water. So this is the reason why helium gas is used. So these are some of the properties you have to go through. So this is all about noble gas and the some important compounds of noble gas. So hopefully you enjoy the class. Okay, tata, bye bye.